Hello, hello. I'm Breton, one of our MCAT tutors here at Inspira Advantage, where we help students get accepted into med school and other professional programs. We're going to finish off our cardiovascular system series with an in-depth walkthrough of the question you are likely to see some sort of variant on the MCAT. The AAMC loves to design questions that test multiple sections. For the cardiovascular system, this often means applying some physics. Let's take a look at our example question today. When assessing the health of the circulatory system, it can be helpful to make approximations to quickly make sure everything is working properly. The most common comparison can be made to a simple circuit where the heart is a voltage source, the flow of blood is the current, and capillaries are resistors. When assessing a patient's heart health, it is found that the left ventricle contracts with 100 millimeters mercury of pressure is generated. Then, an ultrasound was used to measure the speed of blood moving in the brachial artery. It was found that the blood is moving at 25 centimeters per second. What is the total resistance of the body? Now, the first thing we want to do when we see this problem is figure out what type of science is being tested. In this case, it is testing our knowledge of circuits as well as cardioanatomy. The next thing we want to do is figure out what the question is asking of us. Whenever I see a physics problem like this, I like to symbolize the question by writing down the variable I am solving for and setting it equal to a question mark. In this case, it's asking for resistance, which I'll symbolize with an R. Then we want to list out the other variables we're given. We're given 100 millimeters of mercury. We're given our 25 centimeters per second. And that's all. That's all we have so far. The next thing we want to do is see how our units compare to the answer choices. Just by looking at the units, I know that we are going to need to divide our millimeters mercury by distance. I see that because if I look at all of the answer choices, we've got millimeters of mercury, then divided by meters per second. Meters per second is velocity. And to avoid any math confusion later, I'm going to make this conversion now. So over here, we're already in millimeters mercury. That's awesome. But centimeters per second, that is not meters per second. So I'm going to do a simple divide by 100 to get this into meters per second. This will give me a 0.25 meters per second. Wonderful. After getting the units figured out, we can either try to just do division because that's how we get our units to match the answer, or we can call on other knowledge to see if there is an equation to use. Now, in this case, the equation is good old V equals IR. Twinkle, twinkle, little star, V equals IR. We know this because the question told us that the heart is a voltage source. Now we can just plug in our numbers. We know that the 100 millimeters of mercury is symbolically voltage. We're looking for resistance. We know our 25 meters per second is our I, this is our flow rate. So we'll just plug these in. Now we can just plug in our numbers. We know that our 100 is our voltage, so plug in 100 there. We know our current is 0.25, and we know our, well, we don't know our resistance, but we know we want to solve for that, so we'll just put the R in there. Now it's just division. Divide both by 0.25, 0.25. As we solve this out here, 100 divided by 0.25, well, that's the same as multiplying 100 by 4. So we're going to say we get 400 equals our resistance. So now what number matches 400? That's the next step. So we're going to go through our answer choices, and perfect. 400 is answer choice A here. So we can pick A and be confident in choosing 400 millimeters of mercury per meter per second. I hope this video explanation helps you understand the critical way in which the cardiovascular system is often compared to a circuit on the MCAT. Thank you so much for watching our guided example video, and I will see you next time.